So there are mainly three topics today. One is multicast routing design issues and multicast routing classification. So there are actually two topics and both are asked for 5 marks question or 10 marks question also it can be asked that explain different design issues in routing and its classification. So in classification there are some 3 4 different types and they also can be asked as a difference that there are different types of routings and what are the difference between them. So multicast routing design issues and classification, very important question. Then there is the first type of routing which is called multicast routing tree based. So what is tree based multicast routing? And there it is bandwidth efficient multicast routing. So it is called BEMRP. And this BEMRP is actually having 3 stages. Okay. So BEMRP is a very important question for 10 marks and a lot of diagrams you have to draw. It took quite a lot of time to prepare all those diagrams. So try to understand. I'll start with, and I'll go very fast today, initial part, because I have to finish this BEMRP thing today. So these are the topics that we have already seen. So issues in designing routing protocol, that was the first topic. What are the classification of routing protocol? Then we have seen DSDV, table type of routing protocol. Then we have seen the hierarchical routing protocol, that is fish eye. Yesterday we have seen what are the metrics of power hour routing protocol. There were 5 metrics. We had decided, we have discussed that. Then we did a lot of thing about what is meant by clustering. So what is meant by clustering of sensor? Though it is not a part of this chapter, but this question will be asked in IE and final exam. And clustering can be a very good short note. Okay, so a lot of diagrams and all these things are given. You can prepare that. Multicast routing we had started yesterday. We had seen what is meant by unicast, broadcast, multicast. So today we are going to do all these 4 topics which are shown in green. Okay, so these are the 4 topics that we will be doing today. There is issues and a classification of multicast routing, tree-based multicast routing, introduction to that, and mesh-based will not be done today, but in tree-based only, BEMRP, there is bandwidth efficient multicast routing. There are 3 diagrams in that we will do today. This is a diagram from yesterday. We know what is meant by unicast, broadcast, and multicast. So this below diagram is very important. So unicast means one sender to one receiver. Broadcast means one sender to many receiver. Multicast means one sender to many receiver or many sender to many receiver. So in today's case, whatever we will be doing, the BEMRP algorithm, which is very important for today, there we will be doing mainly many sender to many receiver case. So how the routing path is decided, then if the routing path gets broken in between, how to do that repairing, how to do maintenance, how to do optimization, all those things have to be explained by means of diagrams. So drawing diagrams in ad hoc wireless network exam paper is very important. And all the diagrams that I am giving, that will be enough. More than that, you don't require diagrams to be drawn from books. So whatever are there in books, I am giving it to you. And you will find my diagrams, whatever I am giving in your PPT, that is more clearer with much more labeling done on that. So in exam, these diagrams only you are supposed to draw. So design issues of multicast routing protocol. So this is a very important question for 5 marks. So I told you from the beginning that whenever it's an ad hoc network, it will be having shortage of bandwidth. There will be channels where errors will be there, a lot of noises. Node mobility is a very bad issue and very big issue in case of ad hoc node. So all nodes, all sources, all receivers, intermediate nodes, routing nodes, they are continuously moving. Limited energy resources because it is battery powered. Battery is a limited energy resource. Hidden and exposed terminal problem. Enough discussion in the first chapter about hidden and exposed terminal. And limited security. That means it is a wireless communication, and wireless communication is having very less security because your data is continuously going through air. Anybody sitting beside can tap the data and can catch hold of your network and can take over it. Okay. So all these issues are actually the main cause for which the multicast routing might fall or multicast routing might fail. So make the design issue of multicast routing protocol for ad hoc networks is a challenging one because of all these things. So what are the main issues? First issue is robustness. What is meant by robustness? Robust means multi-input, multi-output. And robust means sturdy, very strong. Okay, come any situation, come any kind of external disturbance, the network is not going to fail. The network connectivity is not going to fall. This is what is meant by robustness. So whenever we are designing multicast routing, we have to ensure robustness. So due to node mobility, link failure are very common in ad hoc wireless network. Whenever there is a link failure, data packets sent from one source to another destination is lost. This results in low packet delivery ratio. Multicast routing we have to design in such a way that it should be very robust to sustain mobility of the nodes and achieve a high packet delivery ratio. So even if there is very big amount of node mobility, there is very big amount of node failure and all these things, but then also we have to ensure that as soon as the node fails, there should be some method by which the node connectivity will be restored. Okay, it should be automatically healed up, HEALED, healed. Okay, so that way we can ensure that even if there is a mobility, even if there is a link break, but within very small span of time it will be recovered, and the data transmission reception can go on continuously, so that we can get a very high packet delivery ratio. So robustness is a very important thing in case of any network. Robustness means any disturbance comes, network should be able to withstand that. Okay, to maintain the high data transmission from the source to the destination. Efficiency, whenever there is high data packet transmission, efficiency of the transmission automatically increases. Okay, so robustness actually linked to efficiency. In efficiency, it is repeatedly says that in scarce means constrained or very less. In scarce bandwidth of ad hoc wireless network, the efficiency of the multicast protocol is to be maintained. So though there is very less bandwidth, though there is very less amount of channel available, but then also you should be able to transmit huge amount of data through it. So by proper scheduling, by proper routing, okay, all these things can be achieved. So multicast efficiency is defined as total number of data packets. So this can be a short question, take it out. Multicast efficiency, the definition of that is total number of data packet received at the receiver divided by total number of data and control packet transmitted in the network. So data is the main output. So how much data packet we have received divided by total number of data packet plus control packet. Okay, so control packet is actually creating the environment for proper transmission, but control packets are not carrying any data as such. But without control packet, we cannot get proper transmission. So data plus control packet is the total transmitted packet, and data packet is what is carrying the main information. So if I ask you what is the efficiency of formula for a multicast routing protocol, it is data divided by data plus control packet. That means if control packet is very least 0, that means efficiency is 100%. So routing protocol in should be in such a way that control packet should be as less as possible. Whenever control packet is as less as possible, at that time efficiency is going to be maximum. Control overhead. So these control packets are not only control overhead. So control overhead should be as less as possible. In that case, efficiency will be very high. So to keep track of the members in a multicast group, that means what other nodes are doing, whether they're free, whether they're into some kind of communication. So continuous exchange of control packet happens within the multicast network. So this consumes a lot of bandwidth because control packet exchange does not happen for free. They also need some bandwidth, and over that bandwidth, the control packets are exchanged. But bandwidth in case of any ad hoc network is scarce. That means it is very less. So multicast protocol must ensure that total number of control packets transmitted and maintained in multicast is less. So if control packet is less, data packet is more, in that case efficiency will be more. So we require control packet, but there should not be too much of control packet because too much of control packet will reduce efficiency. So too much of control packet will increase the control overhead. So this is actually an expense for the network. That should be as less as possible. Fourth point, quality of service. So I told you quality of service requires three things. First is data should reach in time, data should be unaltered, and number of data packets should be same as transmitted. So military or strategic application is one of the main scopes of ad hoc network. Here providing quality of service is a must. Okay, so there should not be any data packet loss or as less possible as data packet loss in case of any military network or something. So the main parameter which are taken into consideration for providing QoS are throughput. Throughput means output, that is number of data packet transmitted should be number of data packet received. Delay should be as less as possible. Reliability means the quality of the data transmitted should be same as received data. And delay jitter, so whatever delay is there, that should not be varying. Even if there is a delay, that delay should be constant. Okay, varying delay will make the system non-linear. So quality of service, providing quality of service is a very big design issue for multicast routing protocol. And there is resource management. So there are mainly two resources. One is bandwidth and one is power. Okay, so both resources should be utilized very judiciously, very properly, so that whenever required at that time, maximum power should be used for transmission and reception. So ad hoc network consists of group of mobile nodes. Each node in ad hoc network has limited battery power and limited memory. Hence, ad hoc multicast routing protocol should use minimum power so that the node lifetime will increase. If node lifetime increases, then network lifetime increases. It may be achieved by reducing the number of packet transmissions. To reduce the memory usage, it should use minimum routing table, routing state information. So I told you in DSDV that continuously the table is updated, that which links are being used, which links are not being used, which links are having maximum amount of node with highest battery power. So all this global information continuously is flooded through the network. Okay. And that actually use some kind of memory space. So more is the memory space used and more is the data transmitted, again more will be the power requirement for that. So all these things are interlinked: memory power, computation power, transmission communication power, receiving power, all these things are very much interrelated. Smarter is the protocol, lesser will be the communication power, lesser will be the control overhead, and lesser will be the unnecessary usage of battery. That will actually increase the lifetime of the node, that will increase the lifetime of the network. So resource management means bandwidth management, proper data transmission, and node battery power management, which will increase the node lifetime. So these two are the main issues. Last point, it's called dependency on unicast routing protocol. So if a multicast routing protocol needs to support a particular unicast routing protocol, so unicast means one sender to one receiver, then it is difficult for the multicast protocol to work successfully under heterogeneous network. So multicast means many sender to many receiver. In that case, if somebody says no, one link is there, okay, so suppose there are 10 senders and 10 receivers. But suppose somebody says that no, this transmitter and this receiver link must be maintained. If anything happens, this transmitter and this receiver link, one specific link, it must be maintained at any cost. So that is actually, it is asking for some kind of special concession. Okay, so in that case, designing of multicast routing protocol becomes very difficult. So dependency on unicast routing protocol. So if in multicast routing, a particular unicast routing is must be maintained, in that case, it becomes difficult for the multicast routing protocol to work successfully under heterogeneous network environment. Heterogeneous network environment means every node is having different charge, every node is having different bandwidth, every node is having a different requirement. In that case, to give a special concession to some unicast path, okay, it becomes very different. Okay, so hence it is desirable if the multicast routing protocol is independent of any specific unicast routing protocol. So in Hindi films, it is shown that sometimes there is a class of students, and in that student, suppose son of the minister, he is studying. So that son of the minister is asking for some special concession. Even if he doesn't appear for exams, he should be promoted. So this kind of thing, if it happens, in that case, running the class becomes very difficult for the teacher. Exactly the same thing is happening in case of special unicast routing path maintenance within a multicast protocol. So if it is a multicast protocol, every node has to contribute equally, every node resource has to be shared equally. In that case, if there is a special path which has to be maintained, that becomes little difficult, and actually that damages the whole performance of the network. So there is a very special point, that's the sixth point, dependency on only one unicast routing protocol. So in that case, it will not be possible. So these are all 6 points which are the main design issues of multicast routing. So multicast routing, you have to remember, it is many transmitter to many receiver. That means whole network together is in process of data transmission. So there is classification. So classification, it is multicast routing protocol for ad hoc wireless network can be broadly classified into two types. One is application independent, one is application dependent. Okay, if it is application independent, that means network is there for any kind of application we can use that. Okay, so they are used for conventional multicasting, and application dependent are used for specific application. Okay, so application independent multicast protocol can be classified into mainly there are mainly two types. Okay, so based on topology. Okay, so there are mainly three classes about which the application independent multicast protocol can be classified. The first type is, so among these three types, the first type is based on topology, how the nodes are arranged. Depending on that, we can classify multicast routing. So this based on topology also, there are two types of topology. One is tree based, another is mesh based. So yesterday in clustering, I had shown you what is meant by tree based and what is meant by mesh based. So mesh means within a kind of a circle, every node is talking to everybody. Every node can communicate with everybody. So that is kind of a mesh. And tree means it keeps on getting elongated in one direction. So there are certain cluster head kind of node in between, special nodes in between, and they keep on extending in one direction. Okay, so what is the difference? So these differences are continuously asked as a short question, or maybe they can be asked in IA as small question. So what is difference between tree-based multicast and mesh-based multicast? So in tree-based multicast, single path exists. That is what I told you. So along one main path, so like a tree, along main one stem, there comes different branches. Okay, so that is actually tree-based. So it single path exists between source and the receiver in tree based, but in mesh based more than one path, because all nodes are connected to all nodes, so there may be more than one path in case of mesh based routing. So tree based routing is more efficient, mesh based routing is less efficient. Tree based routing is less robust than mesh based, because there is only single path between the sender and receiver. So somehow if one node or one path fails, the whole network fails in case of tree based. But mesh based is more robust, because even if one path fails, as every node is connected to everybody, if one path fails, another path comes up. Okay, so mesh based is more robust, but mesh based is less efficient, and mesh based has more path between source and receiver. So this is one type of differentiation between tree based and mesh based. So tree and mesh both are topology for network designing. So how the nodes are laid for the network. So depending on that, this is there are two types, tree and mesh. So these differences are very important. Please prepare them for IA for short questions as well as for 5 marks questions. Tree-based multicast again is of two types. So those are the important questions asked in exam. So tree-based multicast can be source tree-based or shared tree-based. So in source tree-based, it is routed at source. So from the source itself, the routing starts. But in shared tree-based, single tree is shared by all sources within multicast group and is routed to the core node. So source tree based is actually it is based on only one node, but shared tree based actually there is one tree which is shared by different other sources. Okay. Source tree based it performs better than shared tree based protocol as heavy loads due to efficient traffic distribution. So source tree based actually performs better than shared tree based, because in shared tree based more scalable than it is more scalable than source tree based thing. So their advantages are compared. So source tree based multicast protocol is having actually it can perform better even if there is a heavy load, but shared tree based, if scalability is there, that means network is very big, in that case we can use shared tree based multicast routing protocol. So there are more important points given in consequent slides. Please check that. A conclusion is drawn here. There is main problem of shared tree based protocol is heavy dependence on core node. That means there is only one single node. If that node fails, shared tree based protocol is actually fails. Hence, a single point failure at core node affects the overall performance of multicast protocol. So it is written here. The single tree is shared by all source node within the multicast group and is rooted as a core node. So if that core node fails, everything else fails. So this core node kind of a centralized access point. If that node fails, everything in shared tree-based multicast protocol fails. So these are small theoretical questions. Just check it. So all this previous differentiation of classification was based on the topology. Topology means how the nodes are configured, how the nodes are put together side by side to design that network. That is called as a topology based classification. Then second one is classification based on initialization. So sometimes what we will find is source is initializing the total routing protocol, and sometimes we will find that the receiver, he is initializing the routing protocol. So there are based on initialization of routing protocol, that is who is initiating the routing process. Okay, sometimes source will initiate that. It is called source initiated multicast routing protocol, and sometimes the receiver, wherever the data is being sent, he will start the routing protocol. So that is called as receiver initiated multicast routing protocol. Some multicast protocols do not distinguish between source and receiver for initialization. We call this source or receiver initiated multicast routing protocol. So there are actually we have found three types. One routing is started by source, one routing is started by receiver. So example is, suppose I am going from here to Bangalore. I know very well what is the path. So I am starting from Belgaum and I am going to Bangalore. So it is started at the source. So at Belgaum only I know what is to be done. Okay, so source point is Belgaum. I am going to Bangalore. I know the whole path. So I'll start from Belgaum. I'll go my way. This is called source initiated routing protocol. Second case, I don't know the path between Belgaum to Bangalore, but some person at whose home I am going to go, that person knows the path very well from Belgaum to Bangalore, and he knows the path. Okay, but he is there at Bangalore, so he is there at the destination point, and he will be telling me, he will be guiding me that you follow this path. So that is called actually as a receiver initiated multicast routing